I'm going to start. Okay, so you can see the screen with this, my Emacs thing, correct?
Yeah.
Yeah, okay. So, yeah, I just wanted to clarify, maybe Diganta, excuse me, has covered these things, but I still wanted to make sure that some of the things that you will need to when you start working on the assignment, which I'll upload after the class today and is due a week from now. So that some of the things that you need to do to complete that assignment, the concepts are clear. Okay, now so here is some C program. So you've already seen, okay, so when I declare some things like I, J, K, X, set of variables, then, so when I assert things like this, are the following true? Okay. Siddhant, I'll ask just to.
Yeah, I think yes, because by default they'll be initialized to 0. Hello?
Correct. Okay, so that is that is true. So that is something that you will have to check sometimes. Now that I'll have to yeah. So I think it is the initial semantics is that, but I'm not sure if C this thing. You're right. Okay, so I think it does follow. So it's been some time. Yeah, so you're right that it does follow the semantics of ANSI C, and therefore I is equal to 0. But do check it out. Maybe you already checked it out. Okay, so with that, this is equal to 0, and these two assertions will be true. Now, you could start out by, if you want to give, arbitrary values for the variables. Okay, that feature is there, and that's what I wanted to emphasize. Okay, please do check. I think you're right, Siddhant, that it does assume that it is initialized to 0 and this asset, but do check it out. Okay, so sometimes I suspect, I just want to make sure that it does not assume that it is arbitrary. But if you really want to start out with arbitrary values, then you could do something like this. Okay, so here in lines 14 and 15, I'm defining two functions. Okay, and notice that the function is specified without any body. Therefore, it'll assume that that function, when invoked, returns an non-deterministic. When I say arbitrary, sometimes I use the term non-deterministic. Okay, so an arbitrary value of that type. So after I do I is equal to non-det, I'm sorry, this should be UN, because I've declared both of them as unsigned. So I'll put it as UN. Okay, so I and J, then say, so then the semantics is that I and J can be any value. Okay, so then is this assertion true? Sandeep, is it? So I forgot. So is that the name of
me? I'm Chandradeep.
Yeah, Chandradeep. I'm sorry, Chandradeep. That's what I meant.
Oh, okay. Number 2.
Yeah. So is this true?
No.
Yes. Can you hear me? Yeah, I asked
yes,
you
I can.
If this assertion is going to be true.
No, it's not true anymore because
What?
they can be different. No, it's not true anymore because they can be different.
Yeah, but one thing to notice is, although yes, because both of them are returning non-det, because the first non-det can return some arbitrary things, not necessarily equivalent to the second invocation of non-det uint, and that's why I will not be equal to j. So that you will have to, I want to emphasize. Okay, sometimes people using CBMC get confused. Okay, so why is this not true? Because each invocation of non-det uint can return an arbitrary number, and therefore these two need not be true. Now, there is another thing which I'm sure Diganta would have gone through, see, prove, or assume. Okay, so that's where you can constrain the way you want to. You can specify any Boolean expression involving variables. Okay, and after that, you start with non-det, and then you can further constrain. Okay, so in this case, I'm starting out to be arbitrary value, but then I can constrain it to be between 0 and length -1. Okay, and that's what see, prove, or assume does. So following that, if is this assertion true, Dhruv?
Yeah, because it'll never happen that I is greater than length. We have assumed that I is less than length.
Yeah, so why? Because see, you're already assuming that this is, and this will be false, and therefore see, prove, or assert 0 should never pass. It should always fail. Okay, but you never will reach that point, and that's why, because the current assumption is contradicts with the contextual condition of the if then else statement. And that's a more precise way of saying is what assert does, in what CBMC does when it encounters an assert, is it kind of accumulates all the assumptions that are either implied by the initial statement or explicitly stated using see, prove, or assumes. Okay, and then what it ships is the negation. Okay, it tries to prove that this thing is valid. Okay. Okay, and the way it does is it takes the negation of that and then proves its checks if it is unsat. Okay, and that's why in this case, because there is an explicit assumption, and this assert appears within the context in which I is greater than length, and therefore that so this will become the negation of that is always unsat, which is false. Okay, so and that's why this is true. So yeah. So I'm repeating the same thing here. Yeah, okay, so that's fine. So again, forget about line 29. Are these two assertions true, Siddhant?
The first one is just an assumption, and the second one, I mean, we don't know what the value of k is.
Is it true? Does it get verified, or is it false?
I think it should be false.
Yeah. Okay, because it can be any arbitrary thing. So you can always, when you take the negation of the thing, it finds it is not unsat, because you can find k and I taking two different values. Okay, so that is about assumptions, but you have to be very careful when you make assumptions. To illustrate that, so you have to be careful that you don't create inconsistencies. Okay, at any point your set of a conjunction of assumptions that you've made should not become false. For example, if you, after making the original assumption on I, that you do something like what is shown in line 40, that I is length, then what will happen? Will the assertion on line 41 fail or succeed, Chandradeep?
It will succeed
Yeah. Yeah. Why so?
because the line 40 and line 21
Oh, we have.
conflict.
Yeah. Okay. Did you understand that, Anli? I mean, I know you kind of you came in a little bit late. Do you understand why? Okay. Why? Okay. Explain again, Chandradeep. I got distracted. Why does it?
Line 40 and line 21 conflict.
Correct. So.
If one is true, the other will be false, and if one is true, the other will be false. So
Yeah,
they are
so assumption itself is false, okay? And since what assert checks, assumption implies us assert, therefore, if assumption itself is false, then it is always true, okay? Therefore, so is that clear? You know, Anli Ben Hirsch, okay, came in late.
Sir, like I heard out. So you.
Hey, who's this?
This is Harsh.
Yeah. Okay.
So first of all, I had if you use CP over assert, it will output sat and unsat only. It can't output valid, right?
No. See, that is the semantics of assertion is this, as I said, it proves this, okay? It checks the validity. So what it does is it takes the negation and proves unsat. That is the semantics of assert, okay?
Okay, it automatically takes the negation.
It automatically takes the goal of assert is, the semantics of an assert statement is that for all possible executions of that program, for all possible input values, for all possible executions, every time control reaches at the point of assertion that it should be true, okay? So it actually checks, that's what it checks is validity of assumption implies assert. And the way that it checks is by, I mean, the only way SAT solvers, and for that matter, SMT solvers can do that is by taking the negation and then checking unsat, okay?
Okay.
So no, there's no business of it doing it. Of course, you could do SAT if you want, but what assert does is this, okay? You can explicitly invoke the SAT solver and SMT solver the way that you want to do very interesting and wonderful things, okay? But what this does is this one, okay? And that's why once your set of assumptions becomes false, then every assertion after that point will be true, okay? Even if those assertions are not meant to be true for your program, okay? See, and that's why I'm saying you have to be careful, okay? When you do, you can't be making inconsistent assumptions, okay? Is that clear? So Anli is here as well, so I want to make sure that it's clear for everyone, including Anli.
Sir, I joined a little late, so I am still finding out what is being done.
Yeah. So, I mean, yes, yeah, one request is okay. I usually start, wait for 5 minutes. It would be good if people, 5 minutes, if they sign on, before 5 minutes. Okay. So I'd appreciate that. Yeah. So I was introducing assumptions. Okay. And Diganta is here as well. I mean, I presume that you would have gone through this thing, no, Diganta? Yeah, but that's okay. So even if you're doing it, so assume is making, constraining the the inputs. Okay, so I first introduce non-det. Okay, so if you want to make variables non-arbitrary at any point, this is one way of doing it. Okay. So, line 14 and 15, for those who showed up late, non-det bool means that it can be anything, okay, because there's no body. So when I invoke it, it can return any value of the return type, okay? So non-det uint can return any arbitrary value of this thing. Sometimes I call those functions as non-deterministic functions. So when I do an assignment like this, okay, as shown in line 17, that means after that assignment, I and j will be some arbitrary value, okay? And then you can make, or you can constrain those assumptions further using assume clauses like I've done here, okay? And I was discussing that. So when you do that, sometimes you will, what you then, after making a whole series of assumptions following an assert, what you actually do is, what asserts semantics is that it checks the validity of all the assumptions that have been made up to that point, okay, via assumes or whatever the initial value. Okay, if there's no assumes, then implies assert, and the way it does is it takes the negation of that and then checks unset. Okay, and that's why once assumption becomes false, then it is automatically, this assumption implies assert will be valid, and therefore it'll be always true. And that is as expected, because if you make inconsistent assumptions, then all bets are off, okay? And so you can't rely on the thing. And that's why sometimes what I do is I make all these complicated assumptions, okay? So when I make assumptions, I usually do this, okay? Like what I've done in line 41, to see if assert 0 succeeds or not. See, assert 0 should always fail. Correct, Annalie? You would expect it to fail, right? What does assert 0 mean?
It assigns 0 to I.
No. I'm just asking assert 0, okay? Assert 0 means you're trying to prove false. 0 here is a Boolean expression, okay? Constant Boolean 0, okay? 0 can never be true, correct? Therefore, assert 0 can never be valid. 0 is always false. It can never be valid, okay? Therefore, it always has to fail, because after all, what assert does is it checks assert. So assumptions implies assert. Since it always should fail, therefore, if you want to check if the set of complicated assumptions that you have made have become inconsistent, by which I mean if they become false, in order to check it, one simple way to do is put in assert 0. If it doesn't fail, then you know, aha, I have made something, some mistake, okay, in the way that I have made my assumption. So this is just a pragmatic that I'm giving you. Yeah. Okay. Good. Yeah. I hope that's clear. So now with arrays, okay, both your the examples in the assignment will be on arrays. Okay, I mean, some you're required to write some programs on arrays and prove certain properties, and therefore, and some of those properties that you want to prove as specifications will need you to kind of implicitly get qualification. So I want to introduce this. I think Diganta, you went through some array examples also, I presume, correct?
Yes, I went through some array.
Okay.
Sorting one by one.
Yeah, so what I will do is, since you have seen some of those things, and I'm assuming that you've attended some of those tutorials, rather than to save some time, I'm going to just double check if you have understood it or not, and therefore I'll go around asking questions, okay, and to see if you have done, and so that way we'll all be clear that we have understood. So on line 48, I have some code to initialize the array, and then I assert. Okay, something on line 49. Is that true or false, Harsh?
That looks like true because it is assigning it to like it's assigning it to all. No, wait. No. That's not true because it's just an uninitialized array. It may be or may not be 0.
Why? I've just initialized it to 0.
I think the
Are
A
you-
will be my answer. This including two different variables.
Yeah, you have initialized.
I'm sorry. That's a mistake. Okay.
Oh,
Okay, let's suppose I did this.
okay. Yeah, now it's true.
Anybody else wants to take
No,
a
right?
guess?
Because I is greater than n. That's an assumption. Like I is greater than the length of the array, so it's not even present.
That is correct. So that's the catch there. Okay. So Harsh, just if you realize that the I is, okay, let me see if I is constrained on but I have constrained I. Okay.
No, on line 40, there's a
No. Oh, okay. So I'm sorry. So after this, let's assume that I do this. Okay, because otherwise everything is true after that because I made an inconsistent assumption there. Yeah.
Yeah.
And let's suppose that
Even now it's false, right? Because in the for loop, you're only going till length -2. So if I is length -1, then
yeah, but remember that any assertion that I prove will be only under the assumption. With assumption implies, okay, there is a default. Okay, what I do this check is, as I've indicated here, assumptions imply assert. Okay.
I mean, even if our assumptions are true, so I could still be length -1, and you're not setting the length -1 to 0.
Okay. That's very instructive. Yes. now it will be true. That's good. Yes. See, I'm making my own mistake. I intended to do up to length. Okay. So if I do this, then it will be true. Correct?
Yeah, correct.
Yeah. Okay. Good. Yes. Therefore, maybe that's what I had meant before AI, because I have this now my array. If I had initialized, okay, so what effect is that you do get, so you are checking for all I, so you kind of get implicitly the effect of universal quantification. Okay, if you kind of constrain this thing, and since you are checking validity under the set of assumptions, so you see you are getting, although it looks like your specification language does not have quantification, explicit quantification, you are getting the effect of the universal quantification. Okay, is that clear? Because what you're checking is the validity of this assumption implies assert. Okay, so which, in other words, you're checking that the negation of that, assuming that the negation this, which means that assumptions and assert, a negation of assert is never is unsat, and therefore you get the effect of universal quantification, kind of at least at the top level. Okay, and so you could. So that's kind of the nice thing about this thing. So you're effectively checking that for all I between 0 and length, my array is actually equal to 0. Okay, so you don't need to. So that's the thing. So is that clear? Okay. Any questions there? Okay. Okay, so what does this do on line 62? Specifically, after I do what I did, this assignment on line 62, will the assert on line 64 is it true? And Anli?
So,
I'm asking Anli.
okay, okay.
First of all, okay, let's take it simple, Anli. So what does this do?
So it assigns value x to the I index of my array.
Yeah, at I, okay?
At
It's
I.
showing value at I. But what does that I, what is I? See, I could be anything
Less than length.
between, yeah, 0 and length, okay? So what it does is, it only sets a particular I, okay, between the element at a particular index in array to X, okay? I don't know which one it is, okay? But it does set something, okay? So so that's why now, given that understanding, is this true?
No, sir.
Yeah. Why?
Because I can be any
Yeah, that's
number from
correct.
0 to length.
That's right. So you're actually, this will, yes. So you can, when you take the negation, of course, there are some i's, indices at which X is not true, okay? I mean, that there are some indices at which the element is not true, and that's why. So that's why I meant when you make this assertion like this, because of the semantics of assertion, checks validity of assumption implies thing, you get the effect of through non-determinism, you are getting the effective checking universally, effective getting checking universal quantification over the indices for the array. Yeah.
Sir, I had a question like,
Yeah.
what is exactly the value of I? Like, isn't it supposed to be like, won't this just throw a compiler error like my array?
No, that is no. So that's why I call these things as annotations. Okay, there are lots of things that can, if you run this thing in ANSI C, it'll throw. Okay, so these are special annotations. Okay, assume and asserts are special annotations.
Mm-hmm.
That I'm only talking about what assert will do under the assumption. Okay.
Okay.
Under the assumptions that are imposed by, excuse me, by the assume annotations. Okay.
So like this,
So,
we are
yeah.
saying this would compile on some compilers, not all, because I might be.
Well, CBMC in CBMC, the front end you could use, you could compile them to something called its own internal representation called go-to-CC. Okay. That compiles it fine, okay? Because the go-to-CC is an internal representation that the front end of CBMC compiles to, which understands all these annotations and then translates them into SMT, SMT formulas or SAT formulas, okay?
No, I still didn't get it. Like, I'm talking about line number 62, like my array of I equal to X. So I is like, this won't throw an error in the case that I is an integer, right?
Firstly, I is an unsigned int here, okay? So
Oh,
if, your question is, if I removed all the assumes and asserts, will it compile? Of course it will compile. No? Why won't it?
because I should be in some kind of integer, I guess, but here it's something else.
In C, that's not a problem, but the problem is I is uninitialized, so it will cause problems.
Uninitialized. Okay, so whatever. Yeah, if it is uninitialized, then it may. Okay.
Probably not in CBMC.
May or may not, depending upon ANSI C. Yeah.
I think, sir,
Whether it gives the compiler error or not, so I'm not an expert on ANSI C compiler, but if it's uninitialized, maybe ANSI C, experts of ANSI C compilers could answer
No,
this.
it won't give a compiler error, but at runtime it might.
Yeah, that's right. So the question was whether it gives compiler. At runtime, of course, this will give.
No, I mean, sorry, I didn't mean compiler. I just meant some kind of error. Like
Yeah, at runtime it does, and that's why. So in order to ensure that in order to ensure that those kinds of things will not happen, you will have to make appropriate assertions here. Okay.
Mm-hmm.
So that's why it gives you the ability to say assume. Okay. So that is, see, that's the thing. I mean, this is software verification. So you will have to, in order to ensure that there are no, I mean, of course you could say, how do you ensure that uninitialized errors don't happen? So one way to do is to make assertions that I is, you can assert before such a my array I is equal to X, you can put an assertion saying that, I is between 0 and length -1, okay?
Okay.
So that is one way to eliminate those kinds of errors through software verification by putting in assertions, okay? And I think some ANSI C have runtime assertion checking as well, okay? They do. So that is one way. You can simulate. In simulation also, thus such checks will be useful, okay? And I think, Diganta, you pointed out that, for array bounds, etc., CBMC does, gives support. It does generate automatically those kinds of assertions, okay?
Yeah.
So
There's a flag.
yeah. So, but here what I'm saying is, the point that I'm making here is that you can make these extra assumptions, okay? And then for me, since I've already made assumptions, appropriate assumptions to make this access error-free, runtime error-free, so it'll take a slightly different meaning here, okay?
Sir, I had another question about the last example. So can you, yeah. So here, even though I is non-deterministic, line 62 and 64.
Constrained non-deterministic. It is non-deterministic, but not completely arbitrary. Okay, go ahead.
Right.
Okay.
Yeah. So, but still, 62 and 64 are referring to the same I, right? So, shouldn't that assertion be successful? Because it should only fail if in the assertion the I is referring to something different than the one in line 62. So yeah.
So I also had a similar, basically the same question. Because I think what might happen, depending on how exactly the semantics is, that
That is okay. No. Why? Because what this is doing is, see, that's where you have to be careful. So it is assigning at a particular I. That's what I does, okay? But if you once again go back to this thing, assumptions imply assert, okay?
I think Siddhant's question is that, does line 62 not add new assumptions to CBMC? Like it now knows what I should be or something like that.
No, I think yeah, I think I'm pretty much correct. Okay, so so you can check. Okay, so why don't you check and then do? So that is my my claim. So once again, it says, so this I will mean that, see, because I itself is non-deterministic here, okay? So it is as though what it does is, if I is between 0 and length minus 1, is my array I is equal to 0. Okay, so that's what it checks. Because it's the same thing as if, if I is after you set I is equal to, constrain I to between 0 and length. If you do I is equal to, if you assert I is equal to 0, what will happen? So you have to get the assumption that for all I, okay, what it checks is the validity of I under the constraint of that thing. So which means that after this, some element of one element at I, okay, will be set to true. Okay. Only one element. Okay, so therefore, but here it'll give, because not all elements are set to false. Although in this case, because I have although I've initialized it to 0, so in this case, what am I checking? Okay, so this one will fail because the assumption is that because my I is not known, right? I could be anything, okay? So I takes some particular value which is non-deterministic, yeah? So it'll not have the effect of setting for every I, yeah? So that's what so this thing means, yeah. Okay, similarly here, so it's the same thing. For example, if I see this is, okay, so do check this. Certainly, if I do this, okay, so the real question is, that's why I also made something like 76. See, prover, assume my array of I is equal to X, okay, instead of my array of I. I'm claiming that 62 and 76 have exactly the same meaning, okay? So this one says that at some particular I, which I don't know which it is, but the only thing I know is that it is between 0 and length minus 1, that element is set to X, okay? Which is what will happen here as well. Okay, but let's check this thing out by next class. Okay, so but if you certainly did this, so that's why I'm saying if you make assumption like this meaning is that it's as though you are, it's like an existential assumption. Okay, so you will have at an I at a particular I which I don't know which it is. It could be anything between 0 and length. At that point, my array of I is equal to X. Okay, so this semantics, when you have non-deterministic, constrained non-determinism introduced, the semantics of assume will simulate an existential semantics. Okay, that you're assuming that thing, and that's why. So that brings the question of how do you get to assume, like if I want to do what I do in line 80, okay, see all this, engineering, you could say that specification engineering is a result of not having quantifiers. I'm going to get to predicate logic, okay, this thing, but since we are trying to do simultaneously making you work with CBMC, so because it does not allow explicitly quantifiers, there are certain semantics that it assigns for its specification language. And that's why I'm saying that this will certainly have the semantics that only that at a particular I, which could be anywhere between 0 and length -1, at which my array will be set to X. So how do you then get to make this assumption? Specifically, will this get me to have the effect of making for all assumption?
If we change, oh, sorry.
Dhruv.
What?
I just now claimed that cprover assume when on line 76 gives me the effect of assuming exists. So my question is, suppose I want to assume that every element.
Yeah, then we just take, so if we have a for all quantifier, we just do not of for all, which would be not of there exists.
Yeah.
So not of there exists or not of 5.
But no. So which means that you're saying that this is equivalent to getting a for all?
So let's see. No, a not of this. So basically, hold on. So you want to check the validity of.
No, there's no checking here. That's the critical thing, because this is not an assert. Okay. In assert, what you're doing is you're checking the validity of assumption implies assert. Okay. That's why you get that trick of getting.
Yes. So for assumption, I think this should do the trick. Like going forward, this should work.
No, but all you're doing here is that this assumption, okay, when you do this, you're assuming that, actually, and let's assume that, since you've already made this thing, so I'm going to get rid of this, okay? So this will be inconsistent with that thing. Suppose I remove that, and then you have cprover assume this thing. It will once again assume that at a particular thing, at a particular I, okay, which I don't know what it is, okay? So it still gives you only existential semantics. Excuse me. What it does is there exists an I between 0 and length at which my array of I is equal to I, okay? Or rather,
it says, so what this assume is going to do is going to find an I and an X such that this assumption is not true, right? Or rather this assumption is true, which would mean that my array of I is not equal to.
Yeah, that's all it means. That means that there exists an I, okay, exists an index between 0 and length at which my array, the array element is not equal to I. That's all it does, okay? It does not have this effect, okay? So don't get, mixed up. In the assumption, in assertions, you get kind of indirectly the semantics of universal quantification over the indices.
I have a question here. So assumptions by themselves are just premises, right? So they're not going to contribute in the final model unless and until we have an assumption.
But they'll only be going into making the final formula, okay? It will be a component of the final formula of whose validity you're checking using assert, okay?
Right.
Yeah,
so,
and that's all.
When
so
you
that's
say,
why, whereas this assumption is just, making, just assumptions, that's all, yeah? That's why when you say I assume a certain I, you're only getting the existential semantics. So by making this, you're saying, oh, there exists an I between 0 and length at which my array I is equal to I, okay? So it's only one element, okay? So you do not get, still you get the existential semantics, so you will not get for all, okay?
The line 76 and 82 don't conflict, right? Because both can be true at same time.
That is true. Okay. but yes, these two assumptions you can have. Who is that made this comment? Chandradeep. Okay. Yes. Yeah. I prematurely did it. Yes, that is still possible. Okay. So you could make my array of I. There can be an I at which it is X, and there can be a different I at which it is I. Okay. Therefore, these two assumptions can be satisfiable. Okay, and therefore they do not necessarily reduce to false. Yes.
Oh, and when we use a non-deterministic variable for assumptions, it's always existential, and when we use it for assertions, it's always universal, right?
You get the impact of universal because what you're proving is the negation of the assertion. Yeah. So you will have to, you have to be careful. Yes, what you end up getting is the negation of the assertion. Yes. Yeah. But what happens is the problem, Chandradeep, I mean, everybody, okay, including Chandradeep. So if you remove this, then, but here I is taking a non-deterministic value, okay? But it is a specific, but it could be anything. See, but there will be a problem because if X is not equal to I, okay, it means that X, you can still make it. X has to be not equal to I because X, okay, it all depends on X, okay? X is, it's not unconstrained. It is X is equal to 0, okay? Assuming that when I do not constrain it, it'll use the, when I do not keep it non-deterministic, it'll follow ANSI C initialization semantics, okay? So here this will say that at I, it is 0, okay? At some specific I, which it could be anything. Whereas here it's the same I, okay, at which I'm saying that it has to be, I. Therefore, there's still a problem, okay? If since I can be anything, this assumption may not be true, okay? So it can be a problem, but you're right that if X is, the problem will happen if X happens to be I, okay? Which in this case, it is not true. X is 0, assuming X is 0, then, so this will be, so if I had an assertion, as long as my assertion is, so what you're doing is my assertion, so there can still be a problem is all I'm saying, okay? That X is, if X is equal to I. For example, what happens, you can ask that question by asking, what happens if I do assert 0, okay? Suppose you don't have any other assertion. So what you're saying is, so what does this mean? So this means you're checking, you go back to this assumptions, okay? Assumptions, which means that you are assuming what is the set of assumptions that you have made, okay? That 0 is less than or equal to I, less than length. There are other things. So okay, I'm sorry, this, and this whole thing, okay?
Should the second and third one not have the local, there exists I?
No, 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 no. See, this is what it does. Okay. So it'll assume this, yeah. And the thing, certainly with assert. So there is a question that I'm raising. Okay, you need to check this. Okay, when you make an explicit assignment. Okay, so that we'll check, and then I'll take a rain check on that. So we will do this. But if you do assume this is what it'll do. And if you have some other assertion, that's what it does. Now, the question is, if it is between 0 and a length -1, this is saying my array of I is equal to X, and I'm assuming that X is equal to 0, okay? So if X is equal to 0, then since my array has not been, since X will take 0, that's the assumption I'm taking. So if I is anything in between these two things, this will not be valid, okay? So, so therefore, because this can be true, this can be made true, and you can still make it false, okay? This is valid only if this assumption is false. So then the question will be if you can make a assumption to be, to be true, it has to be false on all possible values of I. Okay, correct. So this has to be false. Huh? Only then this will be true. So you can check whether that will be true or not. Yeah.
Hello.
Yeah. Diganta?
Yeah, so there is a not there, but it is my I equals to the line number 82 together.
Yeah, I'm sorry. Yes, right. This should be not equals. Yes. Okay.
Sir, I just wrote something very quickly to check this 62 and 64.
Yeah. Why don't you? Can I make you share? Because let's make this thing. So let's get the semantics of CBMC. These are subtle part of CBMC. Okay. So what do you want to show it, or you want to?
Yes. Sure. Okay.
Yeah, go ahead. Yeah, I think this semantics will be slightly different than see, prove, or assume. Okay, I suspect. Okay, so let's check this. Yeah. Yeah, what I'm not sure is int I. Correct. So you have
That is what I think Siddhant's guess was. When you do line 12, it automatically adds a due assumption about I.
Here the verification failed, correct?
No, that's a different one.
Huh?
That's after he added the assert thing on I equals 0.
Yeah, so assert I is equal to 0. Yeah, so this is still consistent. When assert I is equal to 0 and my array, no, assert is fine, okay? You're still assuming that, okay, so after that you're assuming, so, so which one failed, which one? When you run it, I cannot see which one. You're changing and then doing. Diganta, you have to speak up. I think Diganta has muted his thing. Hello?
Yeah, he is not audible to me as well.
Sorry, I had muted myself. I'm really sorry.
Yeah. So please, yeah. So
yeah,
first run one at a time. Yeah.
So I'll firstly run this where
No.
this line number. Okay. Yes, tell me, sir.
Yeah. So if you make, so the first question is if it'll initialize, okay?
Yeah.
Okay?
Is it a non-deterministic initialization? That is what I'm checking here. So
correct.
This one fails. So that means it is non-deterministic. So line 10 fails.
Yeah. So which means that if you don't specify, if you leave it unconstrained, then it assumes that it is non-det. Okay.
Yeah, this is not
one thing that I was not sure about. So we have confirmed that. Okay.
Yes.
So that is good. So
yes. I think we are also using the non-det static.
Yes. So in
you
fact,
could do that. See, I prefer to do that. That's why I always have this confusion. Okay. Since it's been some time since I used to do this. See,
so without this, without this flag, I think it follows like zero initialization. With this flag, it will make it non-det.
Which one?
There's this flag called non-det static that I'm passing to CBMC.
Okay.
With this, it will make it non-det. Otherwise, it will just make the initialization to be 0.
Okay. So with non-det static, then it fails. Okay. Correct? Yeah.
Yeah. So then if I now in this version, I only have this one assume and this one assert. I'm doing my I equals
let's
X.
Let's just keep one thing. So let's not mix non-det. Yeah. Okay. So, non-det static. Let's run it with non-det static, which means it will use non-det static will assume what? Okay.
It will make I non-deterministic.
Non-deterministic. Okay.
Yeah.
Yeah. So now so you're further constraining it to be between 0 and 3. Okay.
Yeah. And then I'm saying my I is equal to X. So I'm assigning it. And then I'm checking the equality. So when I try this,
then it is
success.
That's good. So what Chandradeep, I think, okay. So this semantics is it'll assume that's at that specific value, and that's the specific value that it is done. Yeah. So now let's suppose that you do for all so suppose you do something that I did, so where you assume that instead of assigning my array, replace that with the secret assume. Okay.
So if I replace this one, for example,
I think we should have done this homework. Okay, that's okay. So let's do it interactively.
Yeah. So if I do this, then I think it'll still be successful because
Okay. So C prover assume my array I is equal to X.
So I mean, here it's just assuming this. So there is some non-deterministic I, which is like non-deterministic assignment that is happening here, and then I think for that same I, we are doing all of these things.
Yeah, sorry. So I think yes. Yes. So which means that it is getting an existential quantification assumption, right? Huh?
Yeah, so on the assume it's getting an existential quantification. On the assert, it will get a universal. So if I do this for
quantification.
So I think if
but the other thing is, yeah. So if I can you say that again, yeah.
No. So I was saying that only that assume is an existential, assert is a universal. I think.
That's right. But the semantics is that at that particular for all I, it is not getting the assumption that for all I between 0 and 4 that
no, yeah. So, yeah. So in some sense, both this I and this I are within the same sort of like they're not two separate bound variables in two separate frames, but they're like within the same frame in some sense.
Yeah, I think this semantics will be clearer when I introduce what is called the single static assignment. So which means that there is I is not changed between this line 13 and line 14, and therefore it uses the same thing. Yeah. So for all I, if I is equal to whatever is I naught that it is getting. Yeah. Okay. So this is still existential quantification. Okay. So we are right that assumes has the semantics of an existential quantification. It's only doing that particular I. Okay. And so but I when I use I in the assertion, you will get the effect of universal quantification. Okay.
Yeah. So we can even tell this if I do something like say 0, 0, 0, 1. Sorry. And then if I do something like this should fail. Yeah, it fails. Yeah, and if I have the trace, somewhere it should set I. Yeah, it sets I to 3 over here. So I think, yeah. So this does act like universal as quantification.
Correct. Yeah. And so the moral of the story is that now, if you want to get, this is one way to assign it. Okay, but through assume, if you want to assume something, about a whole bunch of things. Okay, for example, if you want to assume for all I elements in the array that AI is equal to 0, the only way you can do is because you get by default in existential semantics when you use specific I, you have to either do use a for all inside assume, okay, or you have to say my array of I is equal to 0, or so you'll have to do a for all, okay, for all I C prover assume, okay, something like that. Yeah. So suppose you want to did you guys get that? So if I suppose I want to, either you want to make, you can explicitly assign. Suppose I want to assume that all the elements of an array have to be 0, okay, through assume, then I'll have to use a for all or a disjunction, okay, I mean or conjunction. So I'm saying my array 0 is equal to 0, my array 1 is equal to 0, and my array 2 is equal to 0, etc. I have to enumerate that. Okay, so or you can do that inside a for loop. Okay, For example, if you did for all I from 0 to 1, cprover assume I is equal to 0, is equal to 0, then you get that universal assumption. Okay, so this is the price you pay for not having quantifiers. Yeah.
We can also negate everything and use an existential quantifier, right? We can say.
But see, but the thing is, even if you use an existential quantifier, okay, why don't you check that thing out? So even if you use an existential quantifier, you don't get it. You only get that, the way that I explained it to Dhruv. Okay, so this is one way. Okay, to say that everything is due. I mean, but if you say for that cprover assume my array, not of my array k is equal to 0.
We can say not of my array is not equal to 0. In that case, I think it will work. Because in the last example, we still had equality inside as well.
Try it.
So I should put what assertion here is what I'm thinking.
So we are testing the theory that assume, okay, do a cprover assume.
Yeah. And we'll have something like this.
Yeah, you have to assume that I is between
oh yeah, that I'll have
0 and 4. That you will have to do.
So let me just put this here. And here we are saying that something like this. Is it?
Yeah.
Is this what we're doing?
Not equal to 0.
But then that will just be same as saying equal to, right?
Yeah, I mean, that's what I'm saying. We can just use an existential one.
No, but this is the same thing as doing, like, if I remove this and just put an equal to here, right?
Yeah.
Yeah. Because I mean, this will, I think even in the parser stage or somewhere, it will get simplified to this.
Because, not of being not equal to the same thing as saying this. Okay?
Yeah, and if you're, I think we can't like put a not here, like that doesn't make any sense.
No.
Yeah, which is probably what you're trying to do. Right?
Correct. So because you don't have, see, you're getting some effect of universal quantification because you're taking the negation in the, and then in order to check validity, you're taking the negation, and then checking the unsadness. Sometimes you get, okay, in the, you get the effect of universal quantification. But here, it will always be existential quantification, okay? The semantics will always be existential quantification. So if you want to get universal quantification, you will have to explicitly enumerate and then assume for all possible values, okay?
So let's, we can try this, I think. So if I like, say if this does assume, so if we replace with this, if this thing does assume that all elements of my R is 0, then this assertion should fail. So let's see if that happens. Yeah, it does happen. So okay, I have to not do this.
Have you saved it?
Yeah, I've saved it. I have to just delete this thing. I put in that thing before.
Yeah.
It still fails. Okay, so the trace is it says I to 1, x to whatever, and okay, my error is 0 1 0 0. That's what it's saying, setting. Or J I also have to assume like
this. So this only means that it does not set. You can't get universal quantification in assumption. Okay.
Now it should be.
Exists. The semantics will be like the existential quantification. So which means that if you want to get universal quantification and assumption, you will have to
run a for loop, I think.
Yeah, run a for loop, or which is effectively saying you will have to make assumptions, enumerated assumption overall. I think.
Yeah. So if we do this now, this should be successful. Yeah. Oh, sorry. What did it?
For loop is basically.
Oh, sorry.
Yeah, but then you have to make assert equal to 0 though.
Oh, okay. Yeah. Yeah, so this is successful. While if we comment this for loop out and uncomment this guy, this should still fail. Yeah. So yeah, in this case, when we have just this assumption, it actually saying my R is 0001. While in the other case, I think, in the other case it was successful, so it won't print me a trace. But I think over here it's actually setting everything to 0.
Yeah, correct. So I think where you have doubt, okay, make sure that what the semantics of assertion is that it collects all the assumptions up to that point. That implies the assertion at that point, checks the validity of that. But specifically it checks, but it's a matter of detail that it takes the negation and checks unsat. But whereas assumptions, it just takes the conjunction of all those assumptions. And then if you leave it with non-deterministic, you only get it for some, that exists some element in that area for which it is true. Okay, so that is when, with respect to array, that's the semantics that you get. So with this, I think you should be ready to do the assignment, which I'll be uploading. Okay, today. Okay, so I think this was good. So I did not get through to the thing, but nonetheless, this was important, for us to get clarified about the semantics. If you have any questions, please, either you do some experiment or you, get in touch, okay, or raise it next in the next class. So